So I'm going to walk you through two example problems on order of operations with fractions. Here's going to be example number one, and then I'm going to show you example number two like this. And keep in mind that I did give you the answers to each of these problems. So that way when you go through and solve these problems on your own, you'll be able to tell if you did it correct or incorrect. And that's a reason why organization is going to be very important for these problems, because if, let's say, you solve this problem, you know you're supposed to get 45 over 8, but you don't get that answer, that means you made a mistake somewhere. But if your work is messy and it's not organized, it's going to be hard to find that mistake. So my goal in this video is to show you how to apply order of operations to problems like this that involve fractions, and how to organize your work. So it's a suggestion on keeping it organized so that way you don't have trouble following the work that you're doing. So to start off the first example, we have to figure out the order of operations. So we're going to be applying this right here, these 4 steps. Parentheses is step 1, exponents is step 2, step 3 is multiplying and then dividing from left to right, and step 4 is adding and subtracting from left to right. And keep in mind, for steps 3 and 4, when they say left to right, just here's some examples of what I mean. So when you're on, for example, step 3, multiplying and dividing, you're scanning both problems from left to right. So here you can see division appears before multiplication, which means in this case, I'll divide before I multiply. And then in this case here, multiplication appears before division. So that's what they mean by left to right. So the leftmost item, do that first. So the leftmost item is multiplying here, so I do that first. The leftmost item is the division part, so I divide that part first. And that's why you have to be careful if you just follow this strictly as PEMDAS, because it looks like multiplying is before dividing and adding is before subtracting, when it's not. These are grouped together and these are grouped together. Always go from the leftmost item out of those two and the leftmost item out of those two as well. So that's what I mean by working away from left to right. So when I get an example, the first thing I look at is what operations do I have or what's involved in the problem. Here I have division and an exponent and an exponent. So division and exponents is the only thing I have in this problem. So I say, okay, division is here, exponents is here, therefore I'm going to do exponents first. So for my first example, 3/5 to the second power, when you're squaring a number, so when the exponent is 2, it just means you have 2 copies of the 3/5 in this case. So 2 of these, so I wrote them out, and they're multiplied together. So exponents is just a shortcut for repeated multiplication. So 2 of these multiplied together, which I did here, and I just followed the rules of multiplication. 3 times 3, 9, and 5 times 5 is 25. So you see, I almost missed that. Here's my next example, 2/5 to the third power. So I got to simplify this. So remember, in this case, our exponent is 3. The exponent tells us how many of these we're going to write out. So I'm going to do 3 of those, 2/5, 2/5, and 2/5. And this is repeated multiplication. So 3 of these multiplied together. And then we just multiply the fractions together. So all the numerators multiply together, it gives me 8. Multiply all the denominators together, and I get 125. So now, I forgot to mention that this is the way I organize my work. So rather than computing all these values over here, I do it off to the side over here. So you can see it takes up a lot of space. And then once I get my answer to it, I'll take the final answer and I put it over here. So 3/5 to the second power, when I did all the work, I got 9/25. Bring down my division sign. And then same thing here, 2/5 to the third power. You can see that gives me 8 over 125. So 8 over 125. So that was my next step. So again, my answers, it helps clean things up, to keep things more organized so you can figure out what you did. So again, if you make a mistake at some point, you can go back and check your work more easily when things are organized. So when I say organized, just have a flow to your work. One of the best ways I recognize or I see is like keep your flow going downwards, because your answer should always get smaller and smaller as you proceed. And try to organize your work on the side as well, instead of just randomly doing all the work all over your paper and you're trying to figure out where you put something. So try to have some type of organization, some system in place where you can find your information easily. So for the next part, we got to divide these fractions. And if you forgot how to do fraction division, I made a worksheet that I'll put in the description below. I'll put a link to it so you have access to this. So if you forgot how to add fractions with the same denominators or different denominators, I walk you through all those steps here in 2 examples. Similarly, if you forgot how to subtract fractions with the same or different denominators, I do all the steps that are involved, including simplifying your fractions so it's in lowest terms. And then if you forgot how to multiply fractions, I provide 2 examples here. And if you forgot how to divide fractions, same thing here. I provide examples so you can see me walk through the process of dividing fractions. So use this worksheet if needed to get you through these problems. So again, the steps I'm going to show you is from that worksheet that I was telling you. So in this case, to divide fractions, I'm going to use the keep change flip that you probably heard of. Keep this the same, change this to multiplication, and flip this around to be 125 over 8. And then before I multiply these out, I'm going to look for common factors because your answer should always be in simplest form or lowest terms. So I need to do the prime factorization for each of these values. So the 9, I already know it's going to be 3 times 3. That's the prime factorization. 25 is 5 times 5. And then this one, if you don't know how to do the prime factorization, like I said, you can do the work on the side. I know that's going to be 5 times 25. This is prime, this is not, so I'll break this apart, and that's 5 times 5. So I know that 125 is the same as 5 times 5 times 5. So then I know I can rewrite that as 5 times 5 times 5. And then 8, I know it's 2 times 2 times 2. And when you're multiplying fractions, all these multiply together, all these multiply together. But before I do that, I'm going to eliminate the common factors. So the common factors in this case, I can see between numerator and denominators. You can check it above and below, even this way as well. We have a pair of 5s in common, another pair of 5s, and that's it. And remember, the reason why we cancel these out is because 5 divided by 5 is 1. 5 divided by another 5 is 1. So that's why we cancel them out, because it's just equal to 1. And then whatever's left, multiply whatever's left together. 3 times 3 is 9. Times 5, I get 45. And then what's left on the bottom? 2 times 2 times 2, which is 8. So my answer is 45 over 8, which I can see up top the answer was 45 over 8. So remember, if I had a mistake somewhere, like if I didn't get 45 over 8, you can see that my work is easy to follow, so I can figure out where the mistake is. Because again, if your answer doesn't match up, I know there's a mistake somewhere. And again, I'll be able to check these steps quickly. I can check these steps, and I can check these steps. And this is why it's important to show your work so you can see if you make a mistake or not. If you don't have any work, you don't know where the mistake is, and then all you're doing is dedicating yourself to more mistakes. And the goal is to eliminate mistakes so that you can, get through the problems with less stress. So here we have example number 2. Same exact thing. We're going to follow the order of operations. Step 1 is always parentheses. And when I look at this problem, I have this in the parentheses. So I'm going to do 2/5 divided by 1/2 first. So I took the work and put it on the side rather than doing all the work here. I want to keep my work organized, so I'm going to do the calculations here. So I'm going to do 2/5. That's going to become multiplication. And then I flip this around. So we're using that keep change flip method. And then you can see here, these are already all prime. There's going to be no common factors between my numerator and denominator. So I'm just going to multiply across, and I get 4/5. So I know the answer to this part here is 4 over 5. This was in the parentheses. The exponent was there, so don't forget the exponent. And keep bringing down everything else in the problem. 3/5. So 3/5 divided by, this became 4/5. Brought down the exponent, minus 5/10. So now I scan the problem again. What do I have in front of me? Division, exponent, subtraction. And I know out of those 3 items, exponents is before division and subtraction. And remember, there's a lot of steps involved in this, a lot of stuff you have to remember. So if you forget what the order of operations are, just have it written down somewhere on the side. And again, I know I have exponents, division, subtraction, which is here, exponents, division, subtraction. So exponents is before division and subtraction. So I know I'm going to do that next. So you can see, similar to the last explanation, 4/5 to the second part means you have 2 of these multiplied together. I multiply numerators and denominators together, and I get 16 over 25. So again, my calculations are over here to the side. I'm keeping this organized. So I'll copy the problem, 3/5 divided by. This became 16 over 25. Bring down the minus sign and the 5/10. And the good thing about keeping your work organized this way is you can see which order of operation was applied first. So I can see clearly this became this. So I know I did division first in the parentheses. And then from here to here, this is what changed. So I know I did the exponents next. And now look again. Think of it like a new problem. I have division and subtraction. Division is before subtraction, so I'm going to do division next. So I'm going to do 3/5 divided by 16/25. So you can see here I applied the keep change flip strategy to help remember how to divide fractions. And before I multiply, I'm going to do the prime factorization of each of these numbers. These are already prime. This is not prime, but I know that's just 5 times 5. And the 16 is not prime, but that's basically 2 times 2 times 2 times 2. So now I know that when I'm doing multiplication with fractions, I look for common factors between the numerator and my denominator. So I can see here we do have a pair of 5s in common, so that will eliminate. and there's nothing else in common between my numerator and denominator. So I multiply these in the end, I get 15. So whatever's left, multiply them together. On the bottom, we got 16. So 3/5 divided by 16/25 is 15/16. All right, so I put my answer here, 15/16 minus 5/10. So again, you can see my work is very organized. I keep all my calculations as organized as possible. And you can see again, the workflow is going to get smaller and smaller as you proceed to the next step. And then now subtracting fractions with different denominators. Like I mentioned before, if you forgot how to do that, you can go to the notes that I shared with you. Again, the link is in the description. How to subtract fractions with different denominators. You can see here that we need to find the least common denominator, right? So you got to write out the multiples of each numbers, figure out what they have in common. Like in this case, they had a 12 in common. So we're going to do that process next. So here I have my denominator 16 and 10. So I wrote out the multiples of 10 and 16, and you can see that the first number that matches up will be 80. That means I have to rewrite each of these denominators in terms of 80. So you just ask yourself, okay, 10 times what will give me 80? Well, that'd be 8. And what I do to the denominator, I'm going to do the same thing to the numerator. Same idea here. What I multiply 16 by to get 80? In this case, it'll be 5, and I'll do the same to the numerator. And now I just got to multiply each of these pairs together to get me to my next step. So when I multiply these out, I get 75 over 80. Multiply out these pairs, you get 40 over 80. And then all we have to do is subtract these out. We're going to get 75 minus 40, which is 35. And before we say that this is our final answer, for one, I can see it is not the correct answer. But I was going to mention that you always have to make sure in the end, check if you can simplify your answer. In other words, write it in the lowest terms by eliminating common factors between your numerator and denominator. So I'm going to take the 35 and 80 and do the prime factorization. This will be 5 times 7. Those are both prime, so that's all I got to do for this one. 80 is 10 times 8. I could break this down to 2 times 5, and these are both prime. And then the 8, I could break down 2 times 4, and 4 is just 2 times 2. So the prime factorization of 80 would be 2 times 5 times 2 times 2 times 2. Remember, all this means is that when you multiply these prime numbers together, you get back 80. Just like here, when you multiply these, you get back 35. Now I go back to my problem, and I'm going to replace the 35 with the prime factors. Same thing for 80. So this one was 5 times 7 for the numerator. My denominator was 2, 2, 2, 2, 5. So there's 4 2s. 1, 2, 3, 4, and 1 5. So now all we have to do is look for common factors, which I do have a pair of 5s in common, and that's it. So that means whatever's left, multiply. We have just a 7 up top, so that's 7. There's 4 2s on the bottom. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So I get 7/16 for my final answer, which I can see is correct. So again, I highly recommend make sure you organize your work, because again, if you do make a mistake, you need to know what the mistakes are in order to prevent them in your next, the next problem that you try out. Otherwise, you're just committing yourself to more mistakes. Same thing here. You can see there's a workflow to the problem. All my solutions are over here, and I just transfer it back over here to keep this organized.